the integrand. By integrand, I mean the function inside the integral. The integrand is a product of two functions, having the condition that the derivative of one function is simpler. The derivative of one factor is simpler, and the antiderivative of the other factor is not too complicated. It's not more complicated. Okay, I will show you what I mean. The derivative of x is equal to 1. The constant function 1 is simpler than the linear function or power function of x, right? The derivative of one function is simpler. Anybody want to tell me what is the antiderivative of cos of x? Antiderivative of cos of x? Antiderivative of cos of x is equal to, we think which function has the derivative of cos of x. Antiderivative of cos of x is sine of x, right? I hope it makes sense. Sine of x is not more complicated than cos of x. Using our common sense, sine of x, which is the antiderivative of the other factor, which sine of x is not more complicated than cos of x, right? Using our common sense to understand what I mean by simpler and not more complicated. The derivative of x is equal to 1, which is simpler than x. Antiderivative of cos of x is sine of x, which is not more complicated, right? In this case, we are going to use the by-parts formula. We can use the by-parts formula. At least you can think about using the by-parts formula to integrate the function. The key is how to choose u and dv. I will show you how to choose u and dv. The formula is here. I'll just move the integral to here. Choose u to be one of the two factors for which the derivative is simpler. Okay. So we let u be x. So because the derivative of x is simpler, the derivative of u is equal to 1. So which is simpler than x. And the dv is the differential of v. dv is the differential of v. Sorry, I should not have written then in here. You just remember to choose the other function. Now let's recall the integrand is the product of two functions. We choose u to be x. For all the rest inside of the integral, we set it to be dv. We let all the rest be dv. So by that we mean we set dv to be cos of x and then dx. Here is the differential of v. We are looking for a function v. We are looking for one particular function v, having the condition that the differential of v is cos of x times dx. Essentially, v is the antiderivative of cos of x. Okay. Now let's go back to the formula. We have chosen u in here. We have chosen dv in here. The integral in the form of u dv, which is the given integral, is equal to u times v. We need to get u, we need to get v, right? And then we compute the right-hand side of the integral in the formula. To get the right-hand side, in order to compute the right-hand side, we have to get what we need for the right-hand side. Okay. And then we compute du. On the right-hand side, we have du, right? Du is the same as before. It's the differential of u. The differential of u, you take the derivative of the function, and then you multiply the derivative by dx. You have the differential of u. Okay, so du is equal to the derivative of x is equal to 1, right? Is equal to dx. So basically 1 times dx. That's how we get the du. And then I told you how to get v earlier. I will repeat. V, we are looking for a function v having the property that the differential of v is equal to cos of x times dx. It's here. By that I mean v is actually an antiderivative of cos of x. We just need one particular antiderivative. Antiderivative of cos of x is sine of x. To get antiderivative, you think which function has the derivative of cos of x, right? Now we are ready to use the given formula. Now we are ready to use the formula. The given integral now, I will copy it down. The given integral now, if we set u to be x, we set dv to be cos of x and dx. For this function, yeah, probably I'm going to show you how to use the formula. Okay. So the integral is in the form of u times dv, right? So that's u. This part is dv. It's in the form of u dv. Now the by parts formula, and by the way, you can call it by parts formula. People just call it by parts formula. The full name is integration by parts formula. We just call it by parts formula. Okay. Using the by parts formula, it's uv minus the integral of v du. Remember that formula. Okay. I'm going to copy the formula here. It's u times v minus the integral of v du. If the condition is true, by the condition I mean the derivative of one factor is simpler, the antiderivative of the other function is not more complicated. If that's the case, in the new integral on the right hand side, in many cases, is simpler than the original integral. I'm going to show you what I mean. Okay. Now let's plug in the functions. We plug in the functions. U is x. On the right hand side, you have u times v. You have two functions of x. Everything in the formula are functions of x. Okay. U times v minus v du. Now let's look at v du. You're going to see the function, the integral is simpler. V is sine of x. Du is just dx. So do you see the integral is easier to compute? Now all we need is to compute the indefinite integral of sine of x. Sorry, I forgot x in here, guys. We are almost ready to have the final answer. So the final answer is x times sine of x and then minus. So here we are looking for antiderivative of sine of x. So don't be confused with the derivative. Antiderivative of sine of x, we are looking for which function has the derivative of sine of x. Anybody want to write something down? I haven't asked you a question for a long time. What is the antiderivative of sine of x? Antiderivative of sine of x is negative cos of x. Okay, and then we combine with the negative sign here, we turn the sign to plus. Okay, cos of x. After getting rid of all the integration notations, do not forget to plus c. Okay. That is the final answer. Now let me summarize a little bit, okay? So basically I want to repeat something I told you earlier. That's a simple question showing in which case we need to use the by parts formula. Again, the by parts formula, the full name is integration by parts formula.